In this video and the next video, I will show you how to find the intersection point between a line and a plane. So in this subtopic, there are two types of intersection that we need to consider. And before this, in analytic geometry, the intersection of a line and a plane. So can be an empty set, which is no intersection, a point, the line passes through the plane, or a line. So it can be empty set, it can be a point or a line where the line is on the plane. So there are two types of intersection here, which is the parametric line and plane, or the given line can be the Cartesian line or symmetric line and plane. So there's two types of intersection. And the output can be empty set, a point or a line. So first let's consider in this video we'll consider the parametric line and plane. And the next video will be the Cartesian line or symmetric line and plane. So first we look at the parametric line and plane. The intersection point between a parametric line and a plane can be found by, so here we have three steps. First, we will substitute the value of x, y, and z from the parametric equation into the plane. So we have the x, y, z in terms of t, and then we substitute into the equation of the plane. Expand and simplify to obtain the value of t. Then from there, you will get the value of t. From the value of t, again, we substitute back into the parametric equation. Substitute the value of t into the parametric equation to find the intersection point. So first, we substitute x, y, z from the parametric line or the parametric equation into the plane. And then we expand and simplify to find the value of t. From the value of t, we can substitute back into the parametric equation to get the point. So I'll show you example. If you look at the example 5, find the point of intersection between the line. You can see this line. So this line is, if you still remember, this is parametrics. In this video, we will look at the parametrics equation and a plane. So we can see from x, y, z, this x is in term of t, y also in term of t, and z also in term of t. From this x, y, z, substitute in this x, substitute into the plane x, y, and z. You can see when we substitute, from this part, we expand and simplify, and then we'll get the value of t. From this value of t, in order to find the intersection point, we substitute into the parametric equation. Here is the parametric equation. From here, when you substitute, you should get the value of x, y, z, and this is our point of intersection between the parametric line and the plane. So here is the intersection point. So if you okay, now we look at exercise 5. Given a line x, y, and z, now is in terms of s, and a plane x, y, z is equals to 2. Find the points at which they intersect. So how? First, we substitute this x, y, z in terms of s into the equation of the plane. So here, our x from the line 1, from the line, our x is 1 plus 2s. Our y is 2 plus 5s. And our z is equals to 3s. Substitute into this equation. So here is x plus y plus z is equals to 2. So where our x is 1 plus 2s plus y is 2 plus 5s plus z is 3s is equals to 2. So 2s plus 5s plus 3s. So 8 plus 3, this is 10s. 1 plus 2 plus 3. So here is 6 is equals to 2. So 10s is equals to 2 minus 6. 10s is equals to, here is negative 4. S is equals to negative 4 over 10. Or I can simplify in the form of negative 2 over 5. So from this value of s, substitute in x, y, z, we should get the point of intersection. So x is equals to 1 plus 2s, where our s is negative 2 over 5. So here is 1 minus 4 over 5, which is equals to 1 over 5. And then y is equals to 2 plus 5s. So 2 plus 5, s is negative 2 over 5. So here is 2 plus, when I try to simplify this part, I get negative 2. The y is 0. Finally, is the z. Z is 3s. Again, our s is negative 2 over 5. Here we get negative 6 over 5. So therefore, the intersection point is equals to 1 over 5, 0, and negative 6 over 5. So here is our intersection point. So in this video, I've shown you how we're going to find the intersection point between a parametric line and a plane. So how? We substitute the x, y, z into the plane in order to find the value of t or value of s. And then substitute the value of s or t into the parametric equation, which is x, y, z here. We should get the intersection point.